got a Venn diagram. It asks us to complete the Venn diagram and then asks us some probability about that. So over here it tells us all the numbers that need to go into my Venn diagram, whether that's within the circles or around the outside. So first thing I'm going to have a look, it says in set A, which is this one on the left, there's 1, 5, 6, 8 and 9, and in set B there's 2, 6 and 9. Now the first thing I like to identify is the one that's in both. So there's a 9 in both, so I'll stick that in the middle, and there's also a 6 in both. So what I'm going to do, from my list at the top, I'm going to cross off 6 and 9 because they're dealt with, they're done. Now I'm going to have a look at what's just in A. So we've got 1, 5 and 8. So 1, 5 and 8, again crossing those off from the main list, 1, 5 and 8. I've got 2 in set B, which again cross that off from the main list, and just left over then I've got 3, 4 and 7, which can go anywhere on the outside. Right, the next one says, a number is chosen at random from the set. Find the probability that's in set A, N, B, and that N stands for the intersection. So A and B, however you want to look at it. So the numbers that are in A and B, the ones that are in both, are, oh, didn't mean to erase that. What was in the middle? 6 and 9. There we go. The numbers that are in the middle are 6 and 9. So there are two numbers in the middle. We're going to write it as a probability, as a fraction. There are 2 out of a total of 3 numbers in A, so 1, 2, 3, 2 in the middle is 5, plus the 2 is 6, 7, 8, 9, there are 9 numbers, so 2 out of 9 is our probability there. The probability that's in A and B, the intersection, is 2/9. On to question 2. Okay, so Katie invests £200,000 in a savings account for 4 years and it pays a 1.5% per annum compound interest rate, and it wants to know how much interest. So it does say the total amount of interest here, so I just need to make sure I actually work out that amount of interest and not just the amount of money that she has at the end. So to do this, in our calculator, 200,000 times 1 point, when we're going to increase with compound interest, 1.5%, so 0.15. I'm going to do that to the power of 4. It's just going to multiply it by 1.0154 times without having to type it all in. If you type that in on the calculator, you get £212,272.71. Now it asks us to work out how much interest that we have, so we need to take this number and subtract that original 200,000. So subtract 200,000. 0.00 there, no pennies, and it leaves us with a final answer of £12,272.71 of actual interest. Okay, on to the next question, question 3. Okay, so we've got some data in a table and it's going to ask us to draw a frequency polygon. Brilliant, these are the best ones, they're nice and easy to draw. Now it says that there are 80 plants and it wants us to work out the class interval that contains the median. Remember that word class there just means group, so we're looking for which one of these groups contains the interval, the median. Okay, which interval contains the median. So it says that there are 80 plants in total, so we want to find out where the middle of 80 is. So again, if we do 80 plus 1 and halve that, we get 40.5. So we're trying to find out where's that 40.5th plant, not that that actually exists, but in between 40 and 41. So at the moment we've got 7 in the first interval, add 13 to that gets us to 20 plants, add 14 to that gets us to 34, and add 12 to that gets us to 46. Now that's gone beyond the 40.5th plant there, so our median will be in this class. I'm just going to write that down, so 40 to 50. Lovely. Now we're going to draw a frequency polygon. So to draw a frequency polygon, nice and easy, we're just going to use the midpoints of these classes. So the middle of 10 and 20 is 15. The middle of 20 and 30 is 25, 35, 45, 55 and 65. And I'm just going to plot that middle number against each of these frequencies. So let's see, the first one is 15 to 7. So 15 in between 10 and 20 here, up to 7, every 2 squares goes up 1 there, so 6, 7 is there. The next one, 25 to 13, 25 is here, up to 13, 11, 12, 13. See if I can do a couple at a time here. 35 to 14, 45 to 12. So 35 to 14 and 45 to 12 is there. And our last few, 55 to 16, so 16 and 18 for the next two, again in the middles. So 16 and 18, yeah. Okay, up to 16. There, not very well drawn there. And up to 18 for the last one, which is 15, 16, 17, 18. There we go. Now finishing off your frequency polygon with a ruler and a pencil, straight lines from the first dot, join them all the way up to the last one. Okay, really importantly, don't do curved lines there, just nice straight lines between the two. And there's your frequency polygon. Okay, this says write down two things that could be misleading with this graph. Now there's absolutely tons of stuff that could be misleading here, or could be wrong. The first one that I notice is these numbers down here. Now it's not really clear what they mean, 2, 3 and 4. It's a bit bizarre that it doesn't start with 1, so I would just say these are unclear. Okay, that's the unclear numbers on the x-axis. Okay, it doesn't really say what they actually mean. Let's have a look at something else. Something else along the axes maybe. This little section here is a bit bizarre. It goes up in 0.5s, whereas that goes up in 1. So the scale not correct. That's another one that I could say. I mean, that's 2 already. Another one is really, we should draw these up with straight lines as well, not curvy lines. But there you go, we've got two things. We've got unclear numbers on the x-axis and an incorrect scale on the y-axis. Right, so question 5. We have a polygon here. It says it's a hexagon. It doesn't say it's a regular hexagon though, but we have got a hexagon. And it says it's got one line of symmetry. So the first thing that I'm thinking straight away is that's going to have to be important. And this is my little line of symmetry. There are multiple ways of answering this question. I'm going to do it my one particular way though. So if that is a line of symmetry, then this angle B is going to be the same as this angle A. That's the first thing that sort of stands out to me, 117 there as well. That gives us some information. It says FA is the same as BC, which is shown to us by these little lines. And the same on the ones below. It tells us that the other two are the same below, as indicated by the lines down there. Right, so it says angle BCD, which is BCD. This one here is double angle CDE. CDE is here. So if we think about using a little bit of algebra here, which we can do, we can say this is x and this is double that 2x. We don't know what it is. But as well, we have got this line of symmetry, so this is also 2x and this is also x down there. Okay, work out the size of angle AFE. So AFE is this one here, which is the same as angle C over there. Right, so we need to figure out actually what we've got missing now within this hexagon. So to work out the interior angles in a hexagon, if you don't know them, one way that you can think of it, we could do the working out for it. And there's multiple different ways of doing that. We could write a little list. So a triangle's 180, a square's 360, five-sided shape of pentagon's 540, and their six-sided shape of hexagon is 720. So 720 degrees in a hexagon. Again, there are multiple different ways of doing that. We could think of a hexagon as having 6 sides. So our little formula for that, you can do 6 minus 2, which is 4. And 4 times 180 gives us 720. Okay, we can also use the exterior angle to work out as well. So there's lots of different ways of doing this, but I'm going to stick with this one way of doing it. So there's 720 degrees at the moment within this shape. Now we've got 2 of those angles. We've got A and we've got B over here, both being 117. So the first thing that I would do is to subtract the 217s away from 720, which we can do. Or we could just write this as an equation. So we could say 720 take away the 234 there that we've got on those 2 angles, and that leaves us with, I think it's 486. So we've got 486 degrees left over. Now that is split between these 4 angles here. Okay, and we've put some algebra in there. We've put that's 2x, x, x, and 2x. So in total there we've got 6 x's. So if I just say, okay, well, 6x has to equal 486. Okay, those 6 x's have to add up to 486. So if we divide that by 6, let's bring this down, let's divide that by 6, and that tells us that x equals 81 degrees. There you go. So this one's 81, this one's 81, And the two angles above are 2x, so that is 162, and that one there is 162. There we go, so the question only wanted to know the size of this one, so it's 162 degrees as our final answer, down on the answer line. Okay, and that's the end of that question. Again, there are different ways of doing that question, but I'm just going to go over the one way, the one I thought was the simplest way of doing it. You could also have imagined it in terms of a ratio as well, but I've stuck with the algebra for this question. Right, okay, so we've got a cylinder. And it is asking us about, so let's have a look. Each tank is in the shape of a cylinder. There's 3 of them, and it's given us the diameter and the height. He's got 7 tins of paint. Okay, so paint straight away. I'd imagine he's not filling it up with paint, and he's probably painting the outside. So let's have a look. Has he got enough paint to cover completely the 3 tanks? Okay, so we need to work out the surface area of this cylinder. So to start with, the area of a circle is pi r squared, because we've got a circle on the top and a circle on the bottom. The radius of the circle on the top is half of 1.6, 0.8. So the first thing that we can actually do is to work out the radius, the area of the circle on the top. So if we do pi times 0.8 squared, pi times the radius squared, we get 2.01. Now we've got 2 of those, so I'm going to times that by 2, and we get 4.02. I've actually done this on my calculator now, and it's coming. I'm going to keep it a little bit more accurate, so I'm going to get 4.021, and that's for the circles. Okay, the top and the bottom. 4.021. That's in meters, so meters squared. Next thing I have to work out is that curved area around the outside. Remember, if we unravelled that, we'd have a rectangle. Okay, so if we unravelled it, and that has a height of 1.8 meters, and this distance along here is actually the circumference of the circle. And we work out the circumference by doing pi times diameter. Okay, so once we've done pi times diameter to work that out, we can work out the area of that. So we're going to do pi times the diameter, which is 1.6, and then we're going to times that by 1.8, do it all in one step, and we get the answer 9.048, if I round that up, meters squared. Okay, and that is the curved part around the outside. Okay, so that gives us a total area there. If we add those two together, let's add those up. We've got 4.021, add 9.048, and again, I know we're doing this on the calculator, but good little tip, just make sure you write everything down. Okay, because if you have made a mistake somewhere, you are going to get process marks for something like this. So if we add those two together, we get 13.068 meters squared. Now it said in the question, you've just got to remember this at this point, it did say that he's got 3 tanks. We can see that just at the top. It says there, has he got enough to fill 3 tanks? So let's times this by 3, because we want to know the surface area of 3 of these. So if we times that by 3, we get 39.2 meters squared. So that's the total surface area that he has to cover. Now it said in the question, let's go have a look. He's got 7 tins of paint and each one covers 5 meters squared. So if he's got 7 tins, each covering 5 meters squared, then he can totally cover 35 meters squared. Okay, so he can cover 35 meters squared with his paints. Unfortunately, those 3 though are 39.2, so no, he can't. Okay, and we could say 35 meters squared is less than 39.2 meters squared. And on to the next question. Okay, so we've got some typing this into a calculator here. So if you've got a Casio or a calculator that allows you to have these dual levels here, you can type this all in one go. Obviously we don't put this little degrees symbol in here, but we just put 43 in there. So on my calculator I press the square root button, then the fraction button. It'll be a fraction button, looks like this, depending on what calculator you're using. And we just do 2.5 times sine 43 in a bracket, all over 8.2 squared, take away 50.5. Okay, so first things first, write down the full number on your calculator display, 0.3191419,855, and then we'll round it however the question's asking. So it says 3 significant figures. So the first significant figure is the 3, the 1, the 9. So cut off there, and it's a 1 there, so it's 0.319 as our final answer. Okay, question 8. So we've got a right angled triangle. Here's Sarah's method to find the length of BC. I think first things first here, just to identify, that's the hypotenuse, isn't it, on a right angled triangle. So Sarah's using a bit of Pythagoras here, and the working out that she's done looks okay, but that is the sum that you would do if this side was 8, and you'd add them together for using Pythagoras to find the longest side. Now, this is actually to find the shorter side, so actually what we'd want to do is 8 squared take away 6 squared. Okay, so the mistake that Sarah's made is she's added rather than subtracted, and in fact, even if she did subtract, she'd have to swap those over because it'd be the bigger number take away the smaller number. So she used the formula wrong, but we could just say Sarah should have done 8 squared take away 6 squared. On to the next one. So Roy is going to enlarge this triangle with a scale factor of 1.5, and he draws that triangle. Explain why it's not correct. Well, if we have a look, what scale factor has he enlarged it by? Because it looks okay. That is a height of 4. Now, if this is a scale factor of 1.5, 1.5, well, 4 times 1.5 is 6. So the height of the other one should be 6. Let's have a look. 1, 2, 3, 4, 5, 6. Okay, well, no, it's gone way over 6. So that's a height of, I think that's 10 there. 4, 8, 10. Yeah, that's a height of 10. Okay, so it should be a height of 10. He's enlarged it by a scale factor of, let's do 10 divided by 4. 10 divided by 4 is a scale factor of 2.5. So he's used the wrong scale factor. He's done 2.5, and it should have been 1.5. The height should have been 6. On to the next one. The company has to make a large number of boxes. The company has 6 machines, and all the machines work at the same rate. When the machines are working, they can all make the boxes in 9 days. Work out the total number of days based on these amounts of machines being used on particular days. So the first thing is, if you have 6 machines, that normally takes 9 days. So if we do 6 times 9, it's 54 days of work if we had 1 machine. So if we had 1 machine, it'd take 54 days. So let's have a look at how many sort of days of machine work we have here. So on day 1 we have 3 machines working, so that's 3 days of work. On day 2 we have 4, so that's another 4. On day 3 we have 5. Okay, so in total, in the first 3 days, we've done 12 days worth of, or machine days worth of work there. So if we have 54 days in total to actually do, well, 54, take away the 12 that we've done in the first 3, is 42. Now it says on all the other days there's going to be 6 machines being used. So if I do 42 and divide it by 6, that tells me that there's going to be 7 days using those 6 machines for the remaining 7 days. Now it says in the question here, work out the total number of days taken to make all the boxes. Well, we have the first 3 days, okay? We have day 1, day 2, day 3, and then this final part here is our 7 days. So in total there, the first 3 plus the 7 is 10. So 10 days. On to the next one. Mary invests £8,000 in an account for 1 year. At the end of 1 year, interest is added, and she pays tax on that interest at a rate of 20%. And she pays £28.80 in tax. Okay. So what percentage interest, work out the percentage interest rate for the account. So we've got quite a lot going on here actually. Now it says that she pays 20% tax, or she pays tax on this interest rate, yes, so she pays 20% tax, and that is £28.80. So that tax that she pays, that £28.80, is 20%. So if we want to work out the full amount there, we can just turn this back into 100%. So to turn 20% into 100%, times by 5. So if we times both of these by 5, we get £144, which is a 100% interest. There you go. So £144 is 100% interest. Now it says, work out the percentage interest rate from the account. Okay, well, she has £8,000. She puts it into an account. We don't know what the interest rate is, so it's times something, and we've got to call that X. And in the end, she gets £144 interest. So if we add that on, 8,000 plus 144, by the end of this time, she has 8,144. Okay, so I had a question similar to this earlier in the paper. So now we've got to work out what the interest rate is. Now there's two ways to approach this. Obviously I can just solve this using algebra now, or we could just try it out. Okay, I could just pick random numbers in here. I could pick 1.02 and see if it's too big or too small and adjust accordingly. But I think at this point, if you're happy to write this as an equation, it's easier for us to just divide both sides by 8,000 and see what we get as that value of x. So if we divide 8,144 by 8,000, we get x equals 1.018. Okay, now that is not our interest rate for the account. The interest rate is just within the decimal just here. So 1.018 is 1.8%. Okay, and there's the final answer there. Okay, on to question 11. Okay, so we've got some standard form. So the distance between Earth and Mars was 3.9 times 10 to the 7 kilometres. A signal was sent travelling at a speed of 3 times 10 to the 5 kilometres. So that is a distance, that is a speed. How long did it take? So we're looking at speed, distance, time. So again, I'm going to write this as a formula triangle. You might not use these, but I'm going to stick with it just for those that do. And we are trying to work out how long, so we're trying to work out the time, which is distance divided by speed. So the distance is 3.9 times 10 to the 7, divided by the speed, which is 3 times 10 to the 5. And typing that into the calculator, we get an answer of 130. So there's our answer, 130 seconds. On to part B. It says the speed of the signal sent from Earth to Mars was actually less than 3 times 10 to the 5. How will this affect your answer? Well, if it's travelling at a lower speed, it's going to increase the amount of seconds, isn't it? Think about it. If you were driving, if you drive at a slower speed, it takes you slightly longer to get there. So how will it affect your answer? That's important. How does it affect your answer? The answer, it will increase. Easy. Okay, question 12. Right, so we have some fractional indices by the looks of things. 64 to the power of a quarter. Patrick says a quarter of 64 is 16, so the answer is 16. Well, no, that's definitely not correct. When it comes to powers, 64 to the power of a quarter, the number underneath here represents a root. I always like to think of that little line above the 4 as being ground level, and if we have a plant, the root is underneath. So I always quite like that, and the power's on the top. So actually what this wants us to do, it wants us to do the 4th root of 64, which you can type into the calculator and work out if you want, but actually you can just say should be the 4th root. Okay, that's what it means. Right, okay, so we've got some mass and density and volume going on. So we're going to need our density mass volume formula. Density equals mass over volume. And we've got a mixture going on. So we've got some ethanol getting mixed with propylene, and it's going to mix to make this antifreeze. Now, whenever I've got a question like this, I like to keep it all nice and tidy in a two-way table. So I'm going to try and just organise everything like so. So we've got a density, we've got a mass, and we've got a volume for each part. We've got the ethanol. We've got the propylene, and we've got the antifreeze, the final mixture that it's making. Okay, so what information is given to us? It's given us up here, we have the density of the ethanol, so 1.09 grams per centimetre cubed, and also underneath that we've got the density of the propylene, which is 0.97. Now moving on to the line below, it starts to give us litres, which is a volume. So we've got 60 litres of ethanol, 128 litres of propylene, and it's going to make 128 litres of antifreeze. Now obviously in the question here, it's given to us in centimetre cubed, but over here it's given to us in litres. So we could convert these litres into centimetre cubed if we wanted, making sure we remember that 1 litre is 1,000 centimetre cubed. That would be fine to do as well, but I'm just going to leave it in litres. I'm going to leave them all, and it will stay in proportion to one another. So I'm going to keep it as 60 litres, I'm going to keep it as 128 litres, and I'm going to keep it as 188 litres. I'm going to work out the masses here based on if they're in litres. It's a little bit naughty, but it's going to allow us to actually just do this a little bit quicker and a little bit simpler. So to work out the mass, it's density times volume. So to do density times volume, so for this box here, I'm going to do 60 times 1.09. The density is 1.09, the volume 60. So 60 times 1.09, that gives us 65.4. The one next to it, the propylene, same process, 128 times 0.97 gives us 124.16. And masses can be added together. So if we add these both together, we'll get the mass of the antifreeze there, and it comes out as 189.56. There we go. So again, work out the density. Density equals mass over volume. So we've got a volume now of 188 for the antifreeze, a mass of 189.56. So if we write that down, mass over volume, 189.56 divided by 188, we get a final answer of 1.008. And it says to give your answer correct to 2 decimal places. So chopping that after the 8, that rounds it up to a 1, so it's 1.01 grams per centimetre cubed. Okay, on to the next question. Question 14. Okay, so we've got a rectangle, ABDE, and 2 congruent triangles next to it. So congruent meaning exactly the same. So those triangles stuck on the side are exactly the same. Now it says the area of the rectangle is equal to the area of the 2 triangles added together. And then it gives us a little bit more information. It says A to B to A to E is 1 to 3. So A to B is here. If we call that X, we don't know how long it is. And A to E is next to it. So not X next to it, but 3X if it's in the ratio 1 to 3. Okay, so it wants us to work out the length of AE, being this one here. That's what we're trying to work out. Okay, so we can do this using a bit of algebra. Looks like we're going to have to use a bit of trigonometry here as well. But let's see, it says the area of the rectangle is equal to that. So we can start to create a formula already. The area of the rectangle is going to be 3x times x, the 2 lengths of that rectangle, which is 3x squared. There we go. So that's the area of the rectangle. Okay, now we need to work out the area of the triangles. So let's do that over here. Triangle. So to work out the area of a triangle, we're going to use the formula half AB sine C. So we're going to do a half times, let's see, where's A and B. So if I look at this triangle on the right here, let's say 24 is A and 3x is B. So half times 24 times 3x times sine, whatever the angle is, the angle there is 30. Okay, so sine 30. There you go. Well, there's one of our bits of trigonometry we should know. Sine 30 is equal to a half. So sine 30 equals 0.5. No problem though, we have a calculator. So if we type all of this into the calculator, which we can actually work out anyway, a half times 24 is 12, times 3x is 36x, times a half is 18x. So that gives us 18x. Okay, we can type all of these bits into the calculator. We can type in a half times 24 times sine 30 and then times it by the 3 there in front of our x. But not forgetting we have 2 of these triangles, so if we times that by 2, we get a total area of those 2 triangles of 36x. Okay, that's my 2 triangles. Now what it says is the area of that rectangle is equal to the area of those 2 triangles. So if we take the area of that rectangle, which was 3x squared, from here, set it equal to the area of the 2 triangles, which is 36x, from here, and then solve this as an equation. So we can divide both sides by 3. Let's take it in some shorter steps. Let's do it in 2. We could do this in one step. We could divide both sides by 3x, but let's divide both sides by 3 to start with. We get x squared equals 12x. Now let's divide both sides by x, and we get x equals 12. Okay, now the question actually asked us to work out the length of A to E. Now A to E we called we labelled it as 3 lots of x. So we need to do 3 lots of 12, 3 lots of x, and 3 lots of x is 36 centimetres. Okay, 3 lots of 12, which is 36. And there we go, there's our answer for that question. On to question 15. Okay, it says a curve's going to be transformed, and it gives us the transformations here. So it says minus x on the inside of the bracket, minus 3 on the outside. And then it's given us a coordinate. It wants us to know where that coordinate's going to be mapped to. So what happens to 7, 2? Well, the minus x part flips the symbol in front of the x coordinate. So that's going to change the x coordinate to minus 7. The minus 3 at the end takes away 3 from the y coordinate. So take away 3 from the y coordinate. So take away 3 from 2, sorry, is minus 1. And there's our coordinate, minus 7, minus 1. Right, onto a quadratic sequence. Now I know a lot of people do these in different ways, so I'm going to do it my way. But we have to find out the nth term for this quadratic sequence. So the first thing I'll have a look at with any sequence, it says it's quadratic. I'm going to rewrite it so I've got a bit more space. Okay. So first things first, what's the difference between each term? And I'm only actually going to go so far. It's a difference of 6, then a difference of 10, then a difference of 14, then 18, and then 22. Okay, we'll just do them all. Okay, and then I want to have a look at what the second difference is. That's what makes it a quadratic. We've got this second difference, and we've got a second difference here of 4. Okay, so dividing our second difference by 2 gives us 2n squared for the start of our quadratic sequence. Now the way that I do it now is I write down what the square numbers are, and then I double them because it's 2n squared. So the square numbers 1, 4, 9, 16. Double them for 2n squared, 2, 8, 18, 32. Now I just want to have a look at what the difference is between 2, 8, 18, 32 and that original sequence. So I'm just going to write that down. What's the difference? So to get from 2 to minus 1, we subtract 3. To get from 8 to 5, again subtract 3. To get from 18 to 15, again it's subtract 3. So to get from 2n squared, the sequence 2, 8, 18, 32, back to the question, we have to subtract 3. So it's not 2n squared, it's 2n squared, take away 3. And there is your nth term for that sequence, 2n squared, take away 3. Okay, on to the next one. Okay, we've got 4 graphs, and it wants us to say which one's which. So match each graph to the description. So we've got inversely proportional to trigonometrical function, an exponential function, and directly proportional to root x. So inversely proportional to x, a trigonometrical function, an exponential function, and directly proportional to root x. Now I always like to do these just as a sort of pick which one you know to start with. So I think the one that's the most obvious is this one here, the trigonometric function, possibly just because it was the first one that I saw. But that is graph A, and that is the trigonometric function. Okay, then moving on to the next one, have a look at which one you recognise best to start with. For me, it's this one, the inverse function. So I'm going to label that one, the inverse function there. Part number B, letter B, sorry. The exponential function is one where it just keeps going up and up and up. There we go, so that's D. And then we've only got one left, and that's C there. This directly proportional to the square root of x, this one here. Okay, so just process of elimination really. Pick the ones that you know to start with and work through them that way. Okay, on to question 18. Looks like we've got a triple bracket, yeah. So it says it can be written in this form. But it doesn't say actually expand and simplify here, it just expects us to know that's what it wants us to do. So again, different ways of doing this. I pick the first two and expand them to start with. So 2x plus 1 and x plus 3. So expanding that, we get 2x squared plus 6x plus 1x plus 3. And tidy this up before you expand it by the last one. So we have 2x squared plus 7x plus 3. Right, and then there we go. We just need to slot that back in a bracket and times it by that final one up there, that 3x plus 7. So 3x plus 7. And again, times all these out. Does get quite messy at this point. Right. We're going to need a little bit more space. So 2x squared times 3x is 6x cubed. 2x squared times 7 is 14x squared. Moving on to that 7x. 7x times 3x is 21x squared. 7x times 7 is 49x. And then the final two. 3 times 3x gives us 9x. 3 times 7 gives us 21. Okay, and then tidying that all up, let's see what we've got. So we've got our 6x cubed. We've got these two, the 14x squared and the 21x squared. That adds up to make 35x squared. We've got the 49x and the 9x. That makes 58x. And that plus 21 at the end. So there is our final answer. 6x cubed plus 35x squared plus 58x plus 21. On to part B. So we've got an inequality. We've got a squared bracket there, so it looks like we're going to have a quadratic inequality. So first things first, let's expand that bracket. 1 minus x, 1 minus x. So expanding that, just like we have done above, we get 1 minus x plus negative times a negative plus x squared. And tidying that up, you get 1 minus 2x plus x squared. And it says that that is less than 9 over 25. Now this is just personal preference for me, but I like to rearrange this to have the x squared at the start. So I'm going to rewrite all of this. I've got x squared at the start, minus 2x plus 1 is less than 9 over 25. Now we want this right hand side to equal 0, so let's start thinking about how we could get rid of this. So let's times both sides by 25. That's going to get rid of this denominator, times by 25. So we have 25x squared minus 50x plus 25, and that's now less than 9. Now we want to get rid of that 9, so we can just subtract 9 from both sides. And we'll have 25x squared minus 50x plus 16 is less than 0. Now we want to have a look and see about actually solving this. So first things first, can we simplify it? No, there's nothing that they all divide by. 25, 50 and 16 do not have a common factor other than 1, so we can't actually simplify that, which is a shame. So we're going to have to factorise it from there. Now 25, I'm going to imagine that it's 5x and 5x. I could be wrong, it could be 25, but let's have a look. 5x and 5x. Okay, so factors of 16, I can have 1 and 16, or 4 and 4 as my pairing. Now we want to make minus 50 in the middle, and both of these numbers here are both going to get multiplied by 5. So looking at the 1 and 16, I'd have 5 and 16, which I'm not going to make 50 out of, times 16 by 5. Sorry, I'd have 5 and I'd have 80. So I'm not going to make 50 out of those. No. Right, timesing both the 4s by 5, we'd have 20 and 20. No, that doesn't work, so we're going to have to look at another factor pairing. 2 and 8. Okay. Timesing both of those by 5, we'll have 10 and 40. Ah, there we go. That works. 2 and 8. Actually didn't spot those straight away to start with. I don't know why. But there we go. 10 and 40, wasn't it? Now we're trying to make minus 50, plus 16 at the end, so we want minus 10 and minus 40. That's going to make negative 50. Sorry, I'm just being silly there, and I've put 40 in. Minus 8, there we go. Minus 2 and minus 8. That's going to give us the negative 50 in the middle and the plus 16 at the end. So our solutions for these. This bracket here is 2 over 5, and this bracket here gives us 8 over 5. Okay, so there are two solutions. Now there's quite a lot to think about here because it is an inequality, it's not an equation, and we're solving when it is less than 0. Now if you remember, we're looking at and thinking about a curve here, so 2/5 and 8/5. I'm going to have to make this a little bit bigger than it would probably look, but there we go. We'd have a curve looking something like that. Okay, and this would be 2/5 here, and this would be 8/5 here. And the part of the curve that we're actually looking at is below the graph, less than 0, this part here between these two numbers. So the way to write an inequality between two numbers is like this. So x less than, we've got 2/5 on this side and 8/5 on this side. There we go, smaller number on the left, bigger number on the right. That means that the values that we can have are anything between 2/5 and 8/5, which represents this part of the curve here. There we go, there is our answer. It's quite a lot of working out there for a small amount of space. Feels like that needs more space to me, but there we go. Right, question 19, we're looking at some bounds. Okay, so we've got a formula here, and it asks us to work out the upper bound for the value of d. Okay, so we just need to have a quick think here. How are we going to get the upper bound out of something like that? Well, we want the biggest on the top, so the upper bound on the top divided by the smallest on the bottom. So first things first, I'm just going to write the upper and lower bound for both of these. So 26.2. The lower bound to 3 significant figures and the upper bound. So the upper bound is 26.25 and the lower bound is 26.15. And then looking at A, 4.3 to 2 significant figures. So we've got 4.35 as the upper bound and 4.25 as the lower bound. Okay, really important to make sure you write these down. So we want the upper bound of u on the top. So the upper bound of u was this one. So we've got 26.25 squared over the lower bound on the bottom. So the lower bound of a on the bottom, that's 2a, so it's 2 times 4.25. And it says to give it correct to 6 significant figures. Okay, so typing that into your calculator, you get 81.06617664. It wants it correct to 6 significant figures, so 1, 2, 3, 4, 5, 6. We're going to chop it there. So that's going to be 81.066. The 1's going to round up to a 2 as it's a 7 there after my line. Okay. Right, there we go. That's that question done. Okay, so the next one. The lower bound for the value of d is 78.6003, correct to 6 significant figures. By considering bounds, write down the value of d to a suitable degree of accuracy. Well, the upper bound, which we've already written above, was 81.0662, and it's saying that the lower bound is 78.6003. Quite a nice little hint there actually, because if you'd have accidentally done the lower bound above, hopefully it would have matched this one. So let's have a look then. Now it certainly doesn't round the same to any of these amounts of decimal places. Doesn't round the same there, doesn't round the same there. This would be 81, this would still be 78. If we were to round it here, it would be 79 on the bottom one and 81 above, so that doesn't work. So it looks like the only way that these are going to round the same is to one significant figure. To one significant figure, they'd both round to 80. Okay, and that would be to one significant figure. There you go. So my value of d would be 80, and that would be to one significant figure because it's the only way of rounding it, the only method of accuracy there that's going to give us the same for both, and that would be 80. Okay, question 20. Right, now there's quite a lot of different ways of answering this question. Okay, so I'm going to opt for one way of doing it, but essentially we've got to sub one into the other, and it's not a very nice one because we've got to isolate x or y on this one below in order to sub it into the one above. So I'm going to choose to make x the subject for this one on the bottom. So I'm going to do that. Let's have a look. If I subtract 4y from both sides, we'll get 3x equals 7 minus 4y. And then divide both sides by 3, so we get x equals 7 minus 4y all over 3 as my value of x. Now I'm going to sub that, I'm going to call this equation 3. I'm going to sub equation 3 into, I'm going to label these 1 and 2, I'm going to sub 3 into 1. Okay, so replacing that x at the start, this little x squared, with my new equation over here. Okay, so 7 minus 4y over 3 squared minus 4y squared equals 9. Okay, let's expand this bracket then. Let's get rid of this. So expanding this, we get, and it's a double bracket on the top, so you can take your time with that. It's 7 minus 4y brackets 7 minus 4y on the top, which gives us 49 minus 56y plus 16x squared. Again, all over 9 now, not 3 times 3 on the bottom. Minus 4y squared equals 9. Okay, this is going to be quite a long question. I'll change colour because it's going to get a bit lost now. Okay, so we want to get rid of this fraction, so let's times everything by 9, which means we're going to have to times this by 9 and times this by 9, and that's going to give us 49 minus 56y plus 16. Sorry, that should say y squared up there. I don't know why I missed that, just spotted that. 16y squared. And then that 4y squared here is going to become 36y squared, and 9 times 9 is 81. Right, so we've got rid of all these fractions, we just need to make it all equal 0 now. So we need to tidy some of this up. Let's see actually what we've got here. Okay, so I'm going to move everything to the right hand side here. You can do this in a different way, but I'm just going to move everything to the right. I've just noticed that obviously these two here are going to make a negative y squared. Obviously we can keep it all on the left hand side and times it by -1 at a certain point, but I just like to just move everything to the right, and let's have a look. So 36y squared to the right, and actually let's just, you know what, let's just tidy it up here. 16y squared take away 36y squared gives us negative 20y squared. And we have this 49 minus 56y minus 21 squared, no, 20y squared equals 81. Okay, let's subtract that 81 over to this side as well. Minus 81. 49 minus 81 is negative 32. So we have negative 32 minus 56y minus 20y squared now equals 0. Okay, I don't like how this is looking. So let's times everything by, times both sides by -1. That's going to get rid of these negative symbols, and we get 32 plus 56y plus 20y squared equals 0. Now, personal preference here, I am just going to rearrange that to have this y squared at the start. So 20y squared plus 56y plus 32 equals 0. Now from here we need to factorise to solve this. So let's just have a look. I mean, they all actually do simplify. All of these numbers divide by 4. So I'm going to simplify this just to make the factorising easier. Divide it all by 4. We get 5y squared plus 14y plus 8 equals 0. Now, to be fair, at this point we can actually solve it. We could have solved it on the step before, really. This is a calculator paper, so we could use the quadratic equation at this point. I do think this factorises though, so I'm going to avoid it. I just think it's a bit quicker if I can factorise it. It's 5y and y. And then factors of 8, we've got 1 and 8, or 2 and 4. Now we are going to try and make 14 in the middle, which is, one of them is going to get times by 5, so if I times the 2 by 5, yep, 2 by 5 makes 10, with the 4 that's going to make 14. It's all positive, so plus and plus, there we go, that was easy enough. And so we get a y value of negative 4/5 here, and y equals -2 here. Ooh, -2, let's sort that out, -2, there we go. Right, so still need to finish this off now. We need to actually find the x values. So let's have a look. How do we find x? We've got all these equations at the top here. I would definitely opt for this one that we've made. X is 7 minus 4y over 3. So that's the one that I'm going to use. So 7 take away 4y and then divide it by 3. So x equals 7 minus 4y over 3. So let's start with the easy one. When y equals -2, we'll do 7 minus 4 times -2 and divide it by 3. And typing that into the calculator, we get x equals 5. Okay, there's our first one. For the next one, when y equals, where was it, -4/5. So we'll do 7 minus 4 times negative 4/5, all on the calculator, divide it by 3, and we get x equals 17/5, which is 5 into 17, 3 2/5, or 3 2/5. Might just leave it as a fraction there, 3 2/5 or 3.4. Okay, so we have when y equals minus 2, x equaled 5, and y equals minus 4/5, x equals 17/5. Right, okay, a long question there. Definitely one of the worst ones I've seen in a while, that one. Good question though. Right, on to the next one. Okay, so we have a histogram. Okay, so the histogram is saying onions that less than 60 grams are used for pickling. So these ones here are used for pickling. Onions greater than 120, so this set onwards, these are sold at the market. And the rest of the onions are sent to a food processing factory. So that's these other two bars here, they're sent to the processing. Okay, processing, and then these ones are pickling. Right, now it doesn't actually ask us to do anything until this part. It says a pie chart is drawn using the information opposite, and here is our pie chart. So there's the part used for pickling, there's the part sold at the market, and then the x is what it wants us to work out, which is the one sent to the food processing factory, and it says work out the value of x or work out this angle. All right, well, if we go back to our histogram, we can start to actually figure out what the frequencies are within those histograms. Thinking about, hopefully, did we have frequency density on the side? Yes, we did. Brilliant. Okay. So remember to work out the frequency of these bars. You essentially just have to work out the area of each bar, which is the width, class width, and we multiply it by the frequency density. So class width times frequency density. Okay, so class width times frequency density. So let's get rid of all of this. There we go, so we can see this a little bit better. Right, so this first bar then, if I do the class width, which is 60, times it by the frequency density there, which is 2, we had 120 people in there. The next one, class width is 30, times it by 5, gives us 150 for that one. We have a class width of 30 for the next one, and let's have a look. 90 to 120 is 30, times that by 9 is 270. Okay, the next little width is 120 along 2, well, that's not very nice to see. Okay, onto this little bar, that is halfway between 120 and 150, so halfway between 120 and 150 is 135, so that is 15 along. So the width is 15, the height is 6, so I need to do 15 times 6, which is 90. There we go. And then my final bar here is 15 plus an extra 30, that's 45, times the height, which is 2. So that has a frequency of 90. Okay, there we go. Moving back to this pie chart then, let's have a look. So blah, 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 one's used for pickling, one's sold at the market, and one's sent to the food processing factory. So how many in total we use for pickling? So anything less than 60 grams we use for pickling. So that was 120, that first bar there. So 120 we use for pickling. There we are. It's not 120 degrees, but 120 of these onions. Onions greater than 120 grams were sold at the market, so greater than 120. Let's have a look. What was that? That was this one here, the 90, and this 90 as well. So they're sold at the market, so that's 118 total, the two 90s. 180 in this part, and then the rest were sent to the food processing factory. So that was, let's have a look, the 270 and the 150. So if we add those two together, what are we left with? 320, 420 there. So 420 were sent to the food processing factory. Okay, there we go. So it says the angle in the sector for the centre of the food processing factory is x. So we just need to work out what fraction of the circle this is. So if we add all of these up, we've got 120, 420 and 180. They add up to 4, 5, 6, 7, 720. So 720 people, which is quite a nice number actually, because 360 doubled is 720. So actually we don't really even have to overcomplicate this at all. All we're going to have to do is halve all these numbers to get the amount of degrees. If they add up to 720, if we divide that by 360, each onion is 2 degrees. So for 420 onions there, each onion being 2 degrees, divide that by 2, gives us 210 degrees for this one. This one would be 60 degrees, and this one would be 90 degrees. Remember, if we add all of those up, we can just do a quick check to make sure that they actually add up to 360, and they do. Okay, so the actual question's asking us for this one, 210 degrees, so my answer would be 210. Okay, moving on to the next one. Okay, so we've got a question here using a circle. We've got some lines going on. There's a tangent. There's quite a lot going on this question. So we just need to make sure we read this one nice and carefully. Now it says AB is a tangent to the circle. And angle OBA is 30. Point B has this coordinate which is given to us. Point C has a coordinate. P has a coordinate which is given to us, and it wants us to find the value of P. Give your answer correct to 1 decimal place, and you must show all your working. Okay, now the first thing that stands out to me is that obviously if it's a tangent, that's 90 degrees to the radius of this circle. So that has created here a right angled triangle. Now inside that right angled triangle we've got an angle of 30. We don't know what this length is, and we don't know what this length is, but we know that this one here must be 16 because the x coordinate there where it finishes is 16. So just drawing this separately, we've got 16 as our hypotenuse, we've got an angle here of 30, and we can actually work out either of these sides, but this one's going to be quite useful to us here. So I can use a bit of SOHCAHTOA for this. I'm looking for the opposite. I've got the hypotenuse, so I'm going to use sine. Okay, so to work out the opposite, we do s times h. So sine 30, which again hopefully you know is a half, sine 30 or a half times 16, and a half times 16, we don't need a calculator for this one, is 8. So this length here is 8. Now thinking about this as a circle, if the radius is 8, the equation of a circle is x squared plus y squared equals the radius squared. So the equation of this circle is going to be x squared plus y squared equals 8 squared, which is 64. So that's the equation of this circle. So that's going to help if this point P is on the circumference of the circle, which it says it is, then that's going to help us to actually find out what the value of P is there because we know the equation of the circle. So if we sub these coordinates in, let's have a look. We've got x, it says is 3p, and y it says is 1p. So if we sub those into this equation, which I'm going to do over here, we should be able to solve this. So 3p is x, and that's x squared. Y is p, so plus p squared, which I don't need to put in a bracket there because it's just p, and that equals 64. Okay, 3p squared in brackets is 9p squared plus p squared equals 64. So that's 10p squared that equals 64. Divide both sides by 10, we get p squared equals 6.4, and then finish that off, square root both sides, and we get p equals, doing this on the calculator, 2.5298, and some more decimals, but it only wants it to 1 decimal place down here, so I just need to round that off to finish my answer. So 2.5298 to 1 decimal place is just 2.5. There you go, so the value of P is 2.5. Right, now, I think this is the last question. Let's have a look. Yep, last question. Okay, so we've got some bearings. That says Barston is 8 kilometres from Acton on a bearing of 037 degrees, and Chorlton is 9 kilometres from Barston on a bearing of 150 degrees, and it wants us to find the bearing of Chorlton from Acton. Okay, so that is, here's Acton, here's Chorlton, and it wants to know what that full bearing is there. So we've got part of it there, we've got the 37 part, we just need to know what this bit is as well, so we can add it to that 37. So let's have a look and see how we might get there. Now, first things first, I just like to have a look and just see, is there anything that I can fill in just using the diagram? So we know these north lines are parallel. So we've got this angle here, which we can find as a co-interior angle. So if we do 180 minus that 37, that gives us 143 degrees for that angle there. We can take the same logic for this one down here. We might not need it, but we can find this angle as well. We could do 180, take away the 150. Okay, from up here. So that leaves us with 30. Then these two co-interior angles add up to 180. Right, now what can we work out from there? Well, we've got angles around a point here, so we can work out this one. If I do 150 plus 143, we get 293, and take that away from 360, leaves us with 67 degrees. So this here is 67. Okay, we seem to be getting somewhere, and we haven't even started using anything other than some simple angle rules just yet. Okay, so what can we work out using this? Well, we can actually work out this side here now, because we have 8 kilometres here, we've got 9 kilometres here, and we've got this angle, so we can use the cosine rule. So to work out this side here, which I'm going to call A instead of X, so it fits in with my cosine rule, let's call this A. So A squared equals B squared plus C squared minus 2bc cos A. Okay, so A is the angle opposite little a, and then these are B and C. So A squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cos 67. Okay, and if we type that all into the calculator, we get A squared equals 88.7347, and we need to square root that to find out just what A is, so square root both sides, and we get A equals 9.4199. Okay, now it does want our answer just to one decimal place in the end. I think I might just leave this as it is though, just to make sure that I don't get any rounding errors as I work out the next part. So I'm just going to label that up here now. So we've got what that is. We've got 9.4199. Okay, we should be able to work out this angle now. And actually there's a couple of ways that I can work this out. I've got the side opposite, I've got the 9 over there. And I've got another pair of opposites now that I've got A, so I could use the sine rule, or I could use the cosine rule at this point. I actually don't think it matters either way, just whichever one you're more comfortable using. I think as we've already used the cosine rule, maybe we could just stick and use the cosine rule again, but it's completely up to you. You might be more comfortable using the sine rule at this point for an angle. I'm just going to stick with the cosine rule then. So cosine rule, to get an angle, is cos A. You can always make sure you can always rearrange it from the original formula, but cos A equals B squared plus C squared minus A squared all over 2BC. Okay, so let's just have a look, make sure we get our right pieces here. So here's our angle is X, so opposite that is our A squared, 9, and then 8, and this 9.419 will be our other letters. Let's just get rid of some of this stuff. Okay, we didn't need that. Don't need these. Let's get rid of these letters. Okay. There we go. And we're trying to find this one here. Okay, so this is my A. So this is my little a. And then this will be my B and C. Just going to relabel it just to make sure I don't put the wrong numbers in. Okay, so cos A equals B was 8, so 8 squared plus 9.4199 squared minus the A squared, and A for me was 9, okay, minus 9 squared, and that's all over 2 BC, which is 2 times 8 times this 9.4199 again. There we go. Okay, so once we've got the answer there, which I'm not going to write down here, already taking up a lot of room, we need to obviously do the inverse because this is cos A and we want to know what A is. So get your answer to this part, and then we're going to do cos minus 1 using the answer button of your answer, and we get A equal to 61.6, is it, or no, is it 5? 61.57527. There we go. Okay, so A equals 61 points to one decimal place, 6 degrees, 61.6. Let's go back up to our diagram. That there is 61.6 degrees. And now we can add these two together. So we've got the 37 here, we've got the 61 here. So 37, add 61.6, which I've rounded, leaves us with 98.6 degrees to one decimal place. Okay, so we've got 98.6 degrees as our total angle there when we've got 37 plus our 61.6. So let's write that down here, 98.6 degrees. 98.6 degrees is our angle, but let's not forget the question does say find the bearing. So bearings obviously have to have our 3 digits, so it's 0.98 to one decimal place, 0.6 degrees. Okay, don't forget that 0 there to make sure it's a 3-digit bearing. Okay, brilliant, that's the end of the paper. If you like that, if you enjoyed that, if you found it useful, please do like, comment and subscribe to the videos, and I'll see you next time.